Today we're going to talk about parabolas and focus mainly on the concepts of directrix and focus. Now, we're going to basically look at parabolas centered at the origin in this lecture. There's other ways of shifting around you'll see in your homework, but I really want you to focus on the concepts of directrix and focus and not get so lost in the shifting. Now, we have two types of standard forms for equations for parabolas. We have y squared equals 4p times x and x squared equals 4p times y. The only difference here is which term is squared. If the y term is squared, this is a parabola which opens left and right, and if the x term is squared, this is a parabola which opens up and down. Now we need to get the squared term by itself because this 4p is important. Let's look at an example. We have x squared equals 16y. Well, in this case, my 4p is my 16, so therefore my p has to be equal to 4. Now, since this is an x squared term, this is a parabola which opens up and down, and since this is a positive term, it opens up. Now, I went ahead and graphed the parabola for you because I don't really want to focus on the graph of the parabola as much as what the focus and the directrix does. Now, we already agreed that p was equal to 4. P is actually going to give you your focus. Basically what happens, since this opens up and my vertex is at 0, 0, I'm basically told to go up 4 on my axis of symmetry. That's that imaginary line that goes through the vertex of the parabola. Well, in this case, it's just simply my y-axis. So I'm going to start my origin. I'm going to go up 4, and this is my focus. Now, your directrix is actually the other direction from your focus. So since I went up for my focus, I'm going to go down the same amount for my directrix. Notice these two distances are the same. My directrix isn't a point, though. It's actually a straight line. Okay? And in this case, since my parabola opens up, it is a horizontal line. Parabolas open up and down have directrixes that are horizontal line. If this is a parabola opening left or right, it'd have a vertical line as a directrix. The other point I mentioned was that the focus here and the directrix were the same distance from each other. And actually, that's the key here on why we even care about the focus and directrix. It's because every point on this parabola is the same distance from the focus as it is from the directrix. If we sit there and take our focus, draw a point, I picked an arbitrary point here on the parabola. This distance here is the same as this distance. Now, why did I pick this distance? I had to pick this distance because the shortest distance between 2 points is a straight line. However, I want to find the shortest distance between a point and a line. It's a perpendicular distance. So this is actually a vertical line coming up from the directrix. These two distances are the same. If you notice, the origin was the same. It was 4 here and 4 there. In fact, if you pick any point on this parabola, the distance between the focus and that point and the directrix is the same, and that's the key to the focus and the directrix. Let's look at a simple example, graphing in standard form. I'm going to start with equation y squared equals 36x. The first thing I should notice is this is a square term, so this is going to open left and right, and this is positive, so it's going to open right. Now, I know my equation y squared is 4px, so I'm going to set my 4p equal to this 36, and this gives me p equals 9. Now, this is a standard form, and it's symmetric with respect to the x-axis. We know that because it's centered at the origin. So my focus is p0, or in this case, 9, 0, because p was 9. My directrix is the opposite direction, and this is an equation for a vertical line, so this is x is negative p, or in this case, x is negative 9. Now, we know that every point of the parabola is equidistant from the focus and directrix, so we can find points that lie directly above and below the focus. Remember, this parabola, let me show you a graph of it, opens right. Here's my focus. I should be able to go up and find this point and go down and find that point easily. And the way I'm going to do this is I'm going to take my original equation, y squared is 36x. I'm going to plug in my p-value of 9. This gives me y squared is 324. So when I solve, I get y squared is plus or minus 18. So now what I have automatically is 3 points for my parabola. I have the origin, which is the vertex. I have the point 9, 18, and the point 9, negative 18. So if I go to graph this, I can graph my 3 points here, here, and here. Here is my focus. Notice it lies the same distance from this point up here as it does from this point down here. And here's my directrix over here. This is a perfectly shaped parabola. Okay? And really, we only need 3 points to graph a parabola. Those are the easiest ones to get. Now, we can do all sorts of things with this parabola. We can shift it left, right, up, and down, and that's where things get a little bit more complicated because we have to know what to do with this focus. If we shift things to the right, then our focus isn't just going to be P, it's going to be whatever shift we take plus the P. And in fact, you're going to see rules on page 666 for translations of graphs, shifting the vertex up, down, left, or right. The key here is to remember which direction the parabola is opening, up, down, left, or right, and what the focus is going to be affected, up or down or left or right, and it's going to go in. It's going to correlate with which direction it opens. Give this a shot. Let me know if you have any questions. Best of luck.